Okay, so why does, if the thermally stored energy is at point B, then why isn't it over here? Well, the answer is it is in the equation. That represents energy that was transferred from mechanical storage to thermal storage. That indicates work's been done. And so it is included and it's right here. Now it turns out it's going to be negative because it removes energy that was stored mechanically and transfers it to thermal storage. And we'll see how that works out here. All right, so the PE at point A was again 49,000 joules. Let's save ourselves a little time. The KE was 9,000 joules from before. And now let's take a look at the work. Okay, now by definition, work is F cosine theta D. I will let that be equal to 1/2 mv at B squared. All right, so we need values for these. So let's see what those values are. All right, the force is real simple. It's however much force. So it's friction we're talking about, and there's 1,500 newtons of it. All right, and then this is going to be cosine. Now, what angle are we talking about here? Well, let's go up to our cow sliding down. This is going to be the angle between the direction of the force and the direction of motion. All right, so the cow, the friction force in the cow is going to be back up the hill resisting its motion, and the direction of motion of the cow is down the hill, and so the angle between those two is 180 degrees. And this distance is not this height, but rather the distance over which the force is applied. That's important. That's 20 meters. Some parentheses in there. This will be 1/2 times 500 times VB squared. And let's bring our 49,000 joules over here and our 9,000 joules of KE. And so now we again have a conservation of energy equation written out that will allow us to find the velocity at point B. It's true, you may want to find other things, but finding the velocity gives us a good excuse to apply some of these concepts. That's 9,000. All right, why don't you pause it and do the calculation. All right, if you got 10.6 meters per second, that's what I got also. Now, how does this end up working out to removing mechanically stored energy? Well, the answer is this right here becomes -1. And so this is a subtraction. This is a negative number here. So we start with some mechanically stored energy here, and then we subtract some that goes into thermal storage, and that's the amount we end up with. Okay, so the reason why the work term appears on this side of the equation, even though the TE appears over here, is because the sign control, like whether this is positive or negative, occurs within the angle here. And that allows us to make sure we get that right, because if this angle is, for example, 0, then we want this to be able to be added. What you start with plus what changes equals what you end with. And that's really what this says. Here's the mechanical energy you start with, here's the changes, and this is what you end with. And the changes are energy that was stored mechanically going into thermal storage. All right, in the next segment, we'll look at yet another example.